Hello. Do you consider your firewall a critical part of your AI infrastructure? I'm Robin Rodriguez, a solutions architect at AWS. I'm joined here alongside with Casey Braunschweig, a production engineer at Meta, as well as Syed Sharif, a security specialist, SA also at AWS. And we're going to talk about how Meta's used AWS Network Firewall to secure their AI high-performance workloads. And with that, I'm going to pass it over to Casey, who's going to give a little overview of how Meta uses AWS.
So you are probably familiar with Meta, and we serve billions of people a day across our family of apps, but mostly from our production data centers. So we have our own data centers around the world, so you might not be familiar with how we use AWS. As you might expect, we don't use AWS for the bulk of that huge workload. We use it for certain specialized capabilities, things that augment what we do in our data centers. And so as a result, one of the things we have to do is tightly integrate the individual workloads in AWS with what we do in our data centers. We manage all of that infrastructure from a virtual development environment that exists as part of our production infrastructure. Nobody's managing this stuff from laptops. And we also deploy in AWS with sort of typical AWS best practice, individual workloads in individual accounts owned by the service teams that own that individual service. Right? So let's look at a typical workload before we get to the AI fanciness. So this is probably pretty familiar to you, but a workload deployed in AWS inside of a VPC is typically focused on one particular sort of workload, a set of instances that serve some workload, and we typically deploy that alongside a bastion host that's used for administrative purposes. And so most of the dependencies for this are going to be local to that VPC, right? Most of the ingress and egress traffic here is from our production environment, from our data centers, right? You've got administrative, like SSH coming into that bastion host, maybe some like clients and service requests coming into that workload from the outside. It might be reaching out to our production data centers for some service dependency, something like that. But that's the bulk of the ingress and egress here, right? Most of the dependencies are region local. They're accessed through VPC endpoints. We may have some vendors or partners we need to integrate with, but that's pretty limited. And so using the internet is pretty limited in something like this. This is a service workload, right? This is also something you would stamp out. So you would say deploy this in one region and then deploy it in multiple regions for resiliency or to be close to certain clients, things like that. So what do you need a firewall here? You've already got security groups, network ACLs. Like, what do you need a third layer of firewalling for? There's a couple of use cases that network firewall can be helpful here. One is that because our data centers are so large and numerous, the IP space to describe those data centers is actually quite large. So trying to put together a list of CIDR blocks to describe it, like, you're quickly running up against the limits of what you can do with a security group. You need more rules than that. And if you want to get granular and start limiting that down, you might need hundreds of rules, hundreds of CIDR blocks, and it's just not possible with security groups. Also, some vendors and partners may not be able to give us a set of IPs for the endpoint we need to integrate with. They may only be able to give us a DNS name, and that's just not something we can do with security groups. So we need another firewall. We need something like network firewall. But you guys wanted to hear about AI, so let's talk about an AI workload. We're doing a bunch of stuff with AI, and in AWS in particular, we're deploying HPC clusters for AI research. So very large GPU clusters, and these are not used by service teams running a production service. These are primarily used by AI researchers doing research workloads. And what that means is instead of a service that people only log into administratively, you've got researchers logging in and day out, doing ad hoc things within the HPC cluster, which really changes the nature of their requirements for egress access to the internet, right? They're doing new things, pushing the boundaries every day, looking at benchmarks, looking at other research, working with new partners all the time. This changes very quickly, and so we need to be very flexible and reactive to the kind of access to the internet that they need. But at the same time, we have not only our normal level of security requirements, but there's a whole nother list of requirements unique and specific to AI data that we also have to meet. So we've got these things pulling in opposite directions. It's quite a challenge. The other thing that's different with HPC is that HPC clusters are not deployed in a bunch of regions just based on reliability. Instead, they're typically special snowflakes in a single region based on something like GPU availability. And so now you're in one region, you can no longer count on being able to deploy all of your dependencies VPC local or region local, right? So now we have this problem of, oh, we need AWS services in another region as well, right? So as you may have run into, right, AWS services, like the AWS public service APIs for some other region are the internet also, right? Can't use VPC endpoints for everything. So that's sort of some of our challenges. And then I'm going to hand it over to Robin, who's going to talk a little bit in general about network firewall before we get to how we actually used it.
Thank you, Casey. So what is it that makes AWS Network Firewall ideally suited for these use cases? And you can think of AWS Network Firewall really as your cloud-native firewall, scaling to hundreds of gigabits per second, supporting hundreds of thousands of connections. You have a rule engine that allows you to leverage AWS managed and created rules, as well as create your own rules from layer 3 to layer 7 to support your individual use cases. And building on that, there are a couple different traffic paths that allow you to protect your environments. I'm going to start off first with egress. We're going to dive quite a bit deeper into that here in just a minute. But egress or outbound, this is your ability to block and prevent data exfiltration or access to unapproved services from your AWS environment. And then secondly, we have the ingress or the inbound path. And so this is where you can prevent this unapproved or malicious traffic from reaching your services from external entities. And then finally, the final traffic path we'll talk about here is what we call VPC to VPC or sometimes east to west traffic. And think of this as how you prevent lateral movement between your AWS environments and secure your service-to-service communications. And I'm going to kick it over to Syed, who's going to go a bit deeper into Meta's deployment.
Thank you, Robin. So now that you know everything about Meta, and you also know everything about network firewall, so let's talk about how Meta uses it for that ingress pattern and that egress pattern. So let's start with ingress. Now with ingress, the first thing Meta does is they have a network firewall in the ingress subnet. So the traffic coming in lands into an ingress subnet from where the network firewall endpoint is. Then from that, after the inspection, the traffic comes into the intra subnet. From there, it goes into the private workload subnets. As you can see, there is a layered approach that Meta has taken to build the security controls that are offered by AWS. The first one is the VPC routing, which ensures that the ingress is only allowed via the ingress firewall to the intra subnet from the internet. Then the network firewall itself. That allows Meta to write those granular CIDRs for Meta's prod IP space, which is massive, and security grapes alone would not scale to. But in addition to that, there are SSH IPs for researchers and others to be able to get to the Bastion host. And then third but last but not least is security groups. And this is where, even though we have the network firewall, taking that layered approach, we also have core CIDR blocks that map back to the source IPs on Meta's prod network. So as you can see, similarly, you also have the egress deployment. In the egress, now we have our private workloads from our private subnets that are now, and again, remember the login pods and the HPC clusters that Casey talked to us about. From there, they're going to an egress subnet where, again, the network firewall endpoint is deployed into. And from there into a NAT gateway out to the internet. Now here, based on those different paths that Casey had shown, you'll see we take the opposite approach. We build the funnel the other way around now. So we start with the security groups. Here it's much coarse because we either limit to none or the Meta prod only or the internet because that's what the use case is. Then in addition to that, we have the VPC routing, which is restricting all egress traffic only to that egress subnet from where the network firewall inspection will occur. And then within the network firewall, you have granular CIDRs blocks for Meta prod. In addition to that, the domain allow listing that Casey alluded to earlier about talking to vendors and researchers and others, vendors and partners that researchers can use. So all that is implemented in the network firewall, and then the traffic is able to safely egress out onto the internet. To talk further about some of the key outcomes, I'll let Casey come and close it.
Thank you very much, Syed.
You're welcome.
So, what did we get from all of this? So now that you know how this works, you can see that we get this level of filtering of CIDR blocks where we keep the existing security groups, network ACLs that we already have, and then layer on something that's a lot more capable of handling the level of rules definition that we need to get granular. So, if we need hundreds or thousands of CIDR blocks to describe a particular use case, we can do that, and it's not a problem. Also, now we get this layer 7 filtering ability. We can filter on domain names. We can filter things above the IP level. And so not only does this allow us to work with vendors and partners and whoever, but also do very granular allow listing for researchers that can also update very rapidly and is very understandable for them. And so make it easy for them to access something new that we didn't allow yesterday, but also keep track of it and keep it very locked down. Let's see. This is not the end. There are things that we can go forward and look at further. So one of them I mentioned was things like S3, places where VPC endpoints are not enough because we have these cross-region dependencies because we can't deploy everything in the local region where the HPC cluster is. If we're willing to accept the limitation of accessing S3 buckets by their DNS names, like individual bucket DNS names, then we can also do that like layer 7 allow listing at the level of individual S3 buckets, which is a pretty cool thing to be able to add. We've been talking a little bit about some of this layer 7 filtering and some of these capabilities that Network Firewall has. This is all without enabling TLS inspection, which people may not know you can do, but we can also enable TLS inspection and you get some additional capabilities that we don't have today. That's something that we're going to look into. An interesting one is VPC block public access. This is a pretty new feature that came out last year. If you're not familiar with it, basically you can completely block access in a declarative way from the VPC to the internet gateway, and then you create specific like subnet level exclusions of where you should be able to get to the internet gateway. So Syed mentioned our routing rules are an important part of forcing all of the traffic through these ingress and egress firewalls. By having those separate ingress and egress firewall subnets, right now we're dependent on those routing rules. If there were to be a mistake, if there were to be some malicious change to a routing table, perhaps you could create a way around the firewall. Well, with VPC block public access, we can have another layer of security that says even if you manage to avoid that firewall, you're not going to get to the internet gateway. That is something that we're waiting on. So there is a compatibility issue with Network Firewall and the specific ingress flow that we use. So I'm hoping that soon AWS will announce a solution to that, and then we'll be able to enable this across these workloads. And then finally, Route 53 DNS firewall is something that you can layer on top of this. And so in some cases, we could block certain traffic patterns at the DNS level before they hit Network Firewall. Again, they would be blocked by Network Firewall, but we save the traffic, save the cost, save those things, and stop that at the DNS level. So we've got more places we can go from here, but I think for a lightning talk, we'll probably call it there, and I will say thank you very much. Appreciate you all, and hand it back to these guys to wrap it up.
Thank you, Casey. So thank you so much. Again, as a lightning talk, we could only go into so much depth. I'm sure you have plenty of questions. Please bring this to us. We'll be standing right here. But in addition, please give us feedback in the survey on your app. That helps us improve and hopefully turn this into a much deeper, more technical, in-depth conversation for a future conference. But thank you again so much for your time. I hope you found this useful and helpful, and looking forward to all of you using all the different layered controls we mentioned today. Thank you.